Welcome to video 2.2D part 1, even more tangent lines and average and instantaneous rates of change.
Derivative. Okay, before we get into that though, I do want to look at numbers 87 through 92 in section 2.2. These are just true or false questions. So here's a question, true or false. If y equals x over pi, then dy dx equals 1 over pi. So they're giving you the function y. They're asking you, is it true that this is the derivative? Well, what happens is, really, pi is a constant, and that's what you have to remember. Pi is not a variable, so there's no quotient rule or anything, which we haven't learned at this point. But this is really 1 over pi times x, and therefore the derivative is 1 over pi. Just like if I asked you for the derivative of 3x, you'd say 3. The derivative of a half x is a half. The derivative of 1 over pi x is 1 over pi. So that is actually true. Okay, here's the next one. If f of x equals g of x plus c, where c is a constant, then f prime of x equals g prime of x. Well, what happens if I do take the derivative of f of x, which means if I take the derivative of the right side, I'll take the derivative, if I take the derivative of the left side, I'll take the derivative of the right side. The derivative of g of x is g prime of x, and sure enough, the derivative of a constant is 0, and hence it is true that f prime of x.
Okay, in exercises 65 through 70, they're going to ask you to find the value of k, it's a constant, such that the line is tangent to the graph, which they give you, of the function. So in number 70, here's the function. Let me just do this. So here's the function, f of x equals kx to the fourth, and they want the line tangent to this graph to be the line y equals 4x minus 1. So the process for number 65 through 70 is to do two things, which is equate the equations and equate the derivatives. So this is basically y equals, this is y equals. They are going to intersect at the point of their point of intersection, which is the point of tangency, since this is the line tangent to the graph. So we equate the equations, kx to the fourth equals 4x minus 1. But then we're also going to equate their derivatives, because at the point of tangency, they're going to have the same derivative, the same slope. So the derivative of kx to the fourth is 4kx cubed. Keep in mind k is a constant. The derivative of 4x minus 1 is 4. That's going to allow us, basically what we have here is a system of equations, and we're going to solve that system by substitution. So I'm going to isolate k in the second equation and get k equals 1 over x cubed. And as I said, right now we're solving the system of equations by substitution. So I'm going to take that value of k and plug it into the first set of equations. So what we have is, instead of kx to the fourth, I'm going to replace the k by 1x cubed. X to the fourth equals 4x minus 1. And of course, that's very easy to solve. You get x as a third. Keep in mind they're asking you to find k, but remember we said k is 1 over x cubed. So k becomes 27, because 1 over x cubed is 1 over 1/27, which becomes 27.
Okay, now we're going to look at the derivative as a rate of change, and that's going to bring us into motion. So there are two different kinds of rate of change, okay, which is an average rate of change and an instantaneous rate of change, okay? And a rate of change means that, if you say the unit rate, that's something per something. Well, of course, that's what slope is, because slope is the change in y over the change in x, and it is a rate because it is a fraction, okay? All right, so if you look at the two situations, if going back to our original introduction to derivatives, if you had a curve right here, y equals f of x, and you had 2 points on that curve, x1, y1, and xy, you could say that the slope of the secant line, the slope of the line through those 2 points, is y minus y1 over x minus x1, okay? If I was to let q equal x2, y2, then that would become y2 minus y1 over x2 minus x1, better known as, of course, since y is the function f of x, that's f of x2 minus f of x1 over x2 minus x1. Now what that is the average rate of change. Very boring word, you'll read right past it, but the average rate of change of a function from x equals 1 to x equals 2, there are 2 points, there are 2 x values, is y2 minus y1 over x2 minus x1, or f of x2 minus f of x1 over x2 minus x1. Whereas the instantaneous rate of change is the slope of the tangent line at that particular point. So you won't be given two values for x, you'll only be given one, and we're talking about the slope of the tangent line, which now becomes the limit as x approaches x1 of f of x minus f of x1 over x minus x1. So the instantaneous rate of change, which, by the way, you'll notice I used a parentheses. If they say rate of change, they mean instantaneous rate of change of the function at a particular value rather than average rate of change, which is from and to. Okay. So, actually, I thought I did this on the next page. I did. Okay. Let me actually cut that and put it back here. Okay, so when you're looking at numbers 93 to 97, okay, it says find the average rate of change. So again, it's going to be very, very important that you pay attention to this word right here, average rate of change, okay? It's a very boring word and it will kind of just disappear off the page for you, but you have got to be looking for that word, okay? The other reason it makes it an average rate of change, it's going to say find the average rate of change of the function over the given interval, and they're going to give you an interval. Then, as a separate question, compare this average rate of change with the instantaneous rate of change. And remember, if it's instantaneous, they don't need to use the word. They could have just said the rates of now. This is confusing, and I hate this question because of the way it's worded. You're going to find the average rate of change, which is just the slope between the 2 points. And then you're going to compare that to the instantaneous rates of change at the endpoint. So what they want you to do is they want you to find the instantaneous rate of change at the first endpoint and the instantaneous rate of change at the second endpoint. So here's what's going to happen. They're going to give you an f of t, f of x, whatever, and they're going to give you an interval. So the first question is find the average rate of change on the interval, which means from t1 to t2. Basically, we're talking slope between 2 points, which is y2 minus y1 over x2 minus x1. Y is a function of x, so we could think of it as f of x2 minus f of x1 over x2 minus x1, but our function's in terms of t, so it's f of t2 minus f of t1 over t2 minus t1. And t1 is 1 and t2 is 2, and they'll give you f of t, so you just plug it in. But then the second part is to compare this average rate of change with the instantaneous rates of change at the endpoint. So they want the instantaneous rate of change at the first endpoint, and they want the instantaneous rate of change at the second endpoint. Instantaneous rate of change is the derivative of the function, so you're going to be finding the derivative at 1. Okay, I'm back, sorry. So you're going to find the first derivative at 1 and the first derivative at 2, which means you have to find the derivative before you can plug in the 1 and the 2. Okay? So here's this is like 94, it's not quite number 94. So here's the function, f of t equals t squared minus 3, and here's the interval, okay? So the first question is find the average rate of change. That is simply the slope between the 2 points, 2f of 2 and 2.1 f of 2.1. So that's going to be y2 minus y1, which is f of 2.1 minus f of 2 over 2.1 minus 2, and that'll give you an answer of 4.1. Then they want you to find the instantaneous rate of change of that function at 2 and also the instantaneous rate of change of the function at 2.1. So there we're going to need the derivative, which you can see is 2t. And I'm simply going to take that 2t, replace t by 2, replace t by 2.1. And what you'll see here is the instantaneous rate of change at 2 is 4. The instantaneous rate of change at 2.1 is 4.2. And sure enough, our average rate of change is between those instantaneous rates of change. And that's the end of video 2.2D, part 1.